Hello, welcome to the course of computer network. So today we are going to discuss about the internet protocol. So here in this chapter we will discuss about ARP, then ARP flooding and ARP spoofing, and next we will discuss about the RARP, and after that the network technologies. So let's start with very first. So here we will discuss about the internet protocol. So there are two type of network protocol like ARP and RARP. ARP stands for Address Resolution Protocol and RARP stands for the Reverse Address Resolution Protocol. So these protocols are used for mapping physical address into logical address or the vice versa. So starting with the very first, let's discuss about the ARP, that is Address Resolution Protocol. Here this protocol is used in network to map logical address to the physical address, or in another word we can say that it is used to map the IP address to the MAC address that is used by a data link layer. So in IPv4 an IP address is 32-bit long, whereas in an Ethernet address or the MAC address is 48-bit long. And here the ARP provides the protocol rules for making this relation and provide address conversion in both direction. So here the table called the ARP cache is used to maintain a relation between each MAC address and its corresponding IP address. This diagram is showing how the ARP request and ARP replies work over the ARP protocol. So here there are four computers in network wants to communicate. So here the computer A, like this computer A, wants to send packet to computer B. But here the computer A only knows the IP address of the computer B but don't know its MAC address. So to get MAC address, here first of all a computer A checks the ARP cache table to find corresponding MAC address to IP address of the computer B. If not found, then the computer A broadcasts a ARP request message in the network, and each computer in the network checks the ARP request and match the given IP address. So after matching the IP address, here the computer B sends a unicast message to computer A with its IP address as well as its MAC address. So this MAC address gets stored in the ARP cache for the future use, and now a computer A can send the packet to computer B because it's know its MAC address as well as its IP address. So here you can see that in diagram the ARP request, for the ARP request it broadcasts the message with the IP address, and after getting this message this particular computer B responds with the respond with its own MAC address with the IP address as ARP reply. Now let's discuss about the ARP flooding. So here in ARP flooding, the affected system sends ARP replies to all systems connected in a network, and this causes incorrect entries in the ARP cache, and here the affected system is unable to connect to any other system in the network, and the affected system is unable to resolve IP and MAC addresses because of the wrong entries in the ARP cache. So this is known as ARP flooding, and the example of this is Woodport virus. Next is ARP spoofing. So here in this, a malicious device sends falsified ARP messages over a LAN, and here the attacker's MAC address is linked with the IP address of the target computer or the service on the network. So after this target device began receiving any data, the ARP spoofing can enable malicious parties to intercept, modify, or even stop data in transit. So here ARP spoofing attack can only occur on a local area network that utilize the ARP, that is Address Resolution Protocol. The next is Reverse Address Resolution Protocol. So this is a networking protocol and it is used by a client computer to request its IP address from a computer network using MAC address or the hardware address. In address resolution protocol, what happens, the computer knows the IP address but it wants MAC address. But here the computer knows the MAC address but it wants its IP address. So it is a protocol by which a device in a LAN can request to have its IP address from a gateway server ARP cache. So a network administrator create a table in a LAN gateway router that maps the physical MAC address to the corresponding IP address. So in this diagram you can see here this host, this is the new host that is connected to this network, and after connecting to this network this host only know its MAC address, it doesn't know its IP address. For that it sends the ARP request is broadcast with its MAC address to find the IP address. Now it's broadcast this ARP request. When this server got this ARP request, then from its cache it finds the particular IP address that correspond to the MAC address and send back the ARP reply, unicast ARP reply to this host with the MAC address as well as corresponding IP address. So here in this way this RARP protocol works. Next is a RARP server. So here all the mapping between the hardware MAC addresses and the IP addresses of the host are stored in the configuration files in a host in the network called the RARP server. So here the server correspond to all the RARP requests, and when RARP server receives RARP request packet, it looks up this MAC address in the configuration file and determines the corresponding IP address. So it then sends this IP address in the RARP reply packet. Next is RARP limitation. So here the limitation of this RARP are each MAC address must be manually configured on a central server, and that's the protocol only conveys an IP address. It means for this we have to add the MAC address to the corresponding IP address in the central server. After that it compared to BOOTP and DHCP, it is non-IP protocol. It means it is not handled by the TCP IP stack on client side. Next is network technologies. Here the ARP network can be used in any type of broadcast network. It is used in LAN technologies like Ethernet, Token Ring, FDDI, IEEE 802.11. Whereas ATM has no broadcast method, but we can use ARP on it as well. Then is RARP network. Here the RARP is available for Ethernet, fiber distribution, data interface, and Token Ring LAN. Next is the message format or the ARP RARP header. So RARP and ARP has same structure of packet. Here these are the field of this packet, and it is 32-bit long. The first one is hardware type. Here it is 16-bit field, and it specifies the type of hardware address. Like for Ethernet it use the value 1. Protocol type, here it is also 16-bit field, and it specifies the type of protocol address. Like for IPv4 it gives the value as 0x0800. Next is header address length. Here it is an 8-bit integer which specifies the size of hardware address in octet. Next is the 8-bit integer which specifies the size of protocol address in the octet. This is a protocol address length. The next is the operation. Here it is a 16-bit field which specifies whether the message is a request message or a response message. Like if it is a ARP request, then it use the value 1. If it is ARP reply, then it is use the value 2. If it is RARP request, then it is use the value 3. And if it is RARP reply, then it is use the value 4. Next is the sender hardware address. Here this field extend up to hardware address length octet, and it contains the sender hardware address. Next is sender protocol address. Here this field extends up to protocol address length octet, and it contains the sender protocol address. Next is target hardware address. Here a field that this field extends for the hardware address length octet, and it contains the target hardware address. Next is target protocol address. Here this field extends up to protocol address length octet, and it contains the target's protocol address. So these are the fields of ARP and RARP header, and it is 32-bit long and size. So this is all about the internet protocol. Thank you.